This video goes with 14.2 out of the Musser book for Mathematics for Elementary Teachers. So in the last video, we proved all different ways to tell if two triangles were congruent. And if you remember, angle, angle, angle was also not one of the proofs that you could use. And the question is why? And what does it mean? So here we have three angles, okay, in a triangle. And actually, even though these angles look like they're equal, they actually are measured slightly off, so they're not exactly equal. And you can see that I made a small triangle out of those three angles. But if I dismantle this triangle and spread these out a little, I could make yet another triangle with, again, those same three angles. And if I split this triangle, separate that, and make them even wider, I can make an even bigger triangle out of those three angles. So what's really happening here? The triangles don't look much different from each other. So what we could say is that they look like they are in the same proportion to each other. And if you can say that they're in the same proportion to each other, then that means that they are similar triangles. So if you take a look at these triangles all together, you can see that they're basically, because they all have the same size angles, they have the same ratio. It looks like the same proportions of the sides, okay? So if that's true, then that must mean that similar triangles will have equal angles and their sides will be in proportion to each other. So how do you use this to show similarity? Well, I'm going to show a page in the book because they do a much better job than I will in doing these illustrations. So here's a page in the book. Again, this is 14.2, and it talks about what you need to show similarity. So you can say that the pairs of corresponding sides are proportional if they have an SAS similarity, so side angle side. You can also say that two pairs of corresponding angles are congruent using an AA similarity. So just if you have two angles, you can say that they're going to be similar. And if all three pairs of corresponding sides are proportional, that has SSS similarity. So again, similar means in proportion. So we're talking about the sides being in proportion. If you have two pairs of corresponding angles being congruent, then they will have to be in proportion. And if you have an SAS, side angle side, you'll also know that that third side is also going to have to be in proportion. So again, similarity has to do with the sides being in proportion to each other rather than saying that anything is equal or congruent. So we're going to do this example in class, but this is why similar triangles are needed in real life. If you're talking about casting a shadow, for example, you know that you're going to have the same angle from the sun. And so you can use the concept of similar triangles to figure out how long the shadow would be or how tall the tree would be or whichever they're trying to ask you. So that's the benefit of understanding similar triangles.